Okay, this is chapter 3.2 through 3.4. We're going to study applications of the standard deviation and measures of relative standing. So the last lecture we looked at how to calculate the standard deviation using a chart. We filled in the columns of the chart and we were able to come up with the values for the variance and the standard deviation. And you will need to do that procedure on web work. Here's a recap of what we've done so far. For a sample, the size is denoted by little n, and for a population, the size is denoted by big N. For the mean, the sample mean is denoted by x bar. The population mean is denoted by x bar. The calculation is still the same. Add up all the values and divide by the size. Okay, here the size is little n, and for a population the size is big N. For the variance, our symbol for sample variance is s squared. Our symbol for population variance is sigma squared. The calculation is slightly different. We have the sum of the deviation from the mean squared divided by n minus 1 for a sample, and for a population the sum of the deviations from the mean squared divided by n. So the formula does differ slightly when you're dealing with a population versus a sample. The standard deviation is simply the square root of the variance. So while the variance symbol is s squared, the standard deviation symbol is s. The variance symbol for a population is sigma squared, and the variance symbol the standard deviation symbol for a population is sigma. And it's simply taking the square root of the variance. Our convention is going to be to round both the variance and the standard deviation to 4 decimal places. Okay, so the last lecture we talked about how to calculate the standard deviation and the variance by hand, and now I'm going to show you how you can do it on the calculator. We're going to first put our data into a list. So using your calculator's stat button and then edit, you're going to put in the numbers 3, 5, 7, and 9 like we did last lecture. I will do that along with you. 3, 5, 7, and 9. So stat. Okay, we have data in here from our last lecture. I don't need it anymore, or you won't need it anymore either. So if you use the up button, highlight the L1, and then hit clear, then hit enter, you can delete it. So let's put in 3, 5, 7, and 9. Data does not need to be sorted for calculating the standard deviation and the variance. Okay, quit the list screen, and that's not what I wanted. Okay, here we are. You're going to run a function on the calculator called one variable statistics. To find one variable statistics, we press the stat button and we go over to the calc menu. Now these 3 words at the top here are menus, so we use our arrow to the right to get over to another menu. Okay, under the calc menu with number 1 highlighted, one var stats, one variable statistics, we're going to hit enter. Okay, here we're asked for a list. Now wherever your data is, that's the list you're going to use. By default it brings up L1. If you had to change that, you just use second and a different list. Okay, I want to go back to L1. Frequency list can be left blank if L1 contains all of your data values. If L1 contains all the data values in your data set, then there's no reason to put any number here for frequency list. Scroll down using your arrow down button with calculate highlighted, and then press enter. Okay, and here's the output that we see when we run one variable statistics. It does give us the mean. It gives us the mean of 6, x bar equals 6. Now the calculator is not going to use mu versus x bar. So if you know that your population, or rather if you know that your data represents a population, it would be your job to recognize that 6 should be denoted as mu. Okay, but the calculation is all the same, so the first row here will give you the mean. Second row, sigma x is the sum of all the data values, which is 24. Sigma x squared is what we get when we sum up all the data values squared, and that will give us 164. Okay, those two rows aren't so important. The next row is important. S, capital S, x is the calculator's way of denoting the sample standard deviation. When we write this on paper, we use a lowercase s. The calculator's notation is capital SX. 2.5819888897. And if we round this to the 4 decimal places that we're going to be using for convention, it's 2.5820, which is exactly what we got when we did this by hand. The next line, sigma x, is the calculator's notation for denoting the population standard deviation. When we write this on paper, we just use sigma. But this sigma x is the calculator's way of denoting the same value, which is 2.2361. Now, because we rounded our variance before we found the standard deviation last class, we don't have exactly the same values. The calculator is giving us actually more precise values than we got when we did this by hand, because we had to round the variance before we took the standard deviation. The calculator gives you a quick and easy way, and it's actually more precise. It's a good way to check your work. Now, for web work, you will need to do homework number 3. Web work homework number 3 requires you to do the standard deviation and the variance in the step-by-step procedure I demonstrated in the last lecture. However, for all questions on the final exam or on the midterm, you can use this calculator function to quickly get you the standard deviation or the variance. Okay. Okay, so the one thing that the calculator does not give you, the output on the calculator does not provide a variance. So to get the variance, what you'll do is take the standard deviation, 2.5820 for the sample, and square it. If you square it, you get back the variance, which comes out to be 6.6667. And if you square the population standard deviation on the calculator, 2.2361, you get 5. So let me demonstrate how to square quantities on your calculator. If we haven't done this already, it's pretty easy. So we write the sample standard deviation, 2.5820, and here's x squared, the x squared key right here. We're going to hit it, which is going to square the quantity, and hit enter. 6.6667. And the population standard deviation, which is 2.2361. If we square that, we get, when rounded to 4 places, okay, more precisely, when rounded to 4 places, this is 5.0001. Okay, so that would be a more precise answer than the 5 I have in our PowerPoint. So when you don't have the variance, you can always look at the value for the standard deviation and square it. Okay, now if you take more decimal points, so 2.236067977. If we square more decimal points, if we take more decimal points for our population standard deviation and square that, we're going to get even closer to the number 5. Okay, so the more decimal places you take for your standard deviation from the calculator, the more precise the calculation for your variance will be.